Okey, Assalamualaikum warahmatullahi wabarakatuh. Ni salam sejahtera semua. Ini baru 14 orang ni, mana lagi 10 orang ni. Ya. Hmm. Okey, Assalamualaikum semua. Please join ya. So hari ni ada beberapa perkara penting lah saya nak explain regarding multiple capacitor placement using evolutionary programming. Okay, please join right now. Thank you. Sorry ya, saya hantar mesej kat group sekejap. Okay, so for today's lesson, actually, I would like to share how to modify the existing EP program, okay, for the purpose of multiple capacitor placement. Okay, program EP yang saya bagi sebelum ni itu untuk single capacitor placement. Single capacitor placement is actually it's not very practical to be used because the improvement on voltage and the losses is not very significant compared to multiple capacitor placement. So kalau you tengok balik bila kita buat single capacitor placement ni, dia punya voltage dia tak banyak yang improve. Okay, walaupun ada improve, it's not too significant. So because of that, we have to conduct multiple capacitor placement at various locations simultaneously. Maksudnya simultaneous multiple capacitor installation. But for the first task that you have to perform is to modify the existing EP program from single placement into multiple capacitor placement program. Okay, untuk hari ni saya nak explain lah dekat mana tempat-tempat yang you kena modify tu. But the modification you have to do by yourself. You kena buat sendiri lah. Okay, so I hope all of you get the source code for EP program on single capacitor placement. Saya dah bagi kan yang ni? Saya dah bagi ke belum? Untuk single capacitor placement using EP. Dah, okay, good. Okay, so today we are going to enhance this program for the purpose of multiple capacitor placement. Okay, so as you can see from the top, so just clear CLC, PIC ni tak ada apalah ya. This is just the standard beginning of any program in MATLAB. Lepas tu kita masuk initialization. Okay, initialization seperti biasalah ya. We have to determine the value of beta, population size, as well as the maximum iteration to be used in EP program. Ini tak kacau lah ya. Tak ada perubahan. No change. Then we go to QD and bus QD, which is on the reactive power loading at the power system. Ini pun tak kacau. Okay. Cuma you kena ubah lah ya, from 14 bus to 30 bus. Okay, you still have to use the IEEE 30 bus power system instead of 14 bus. Okay, 14 bus saya cuma bagi example. You kena guna untuk you punya mini project 30 bus. Okay, ini pun tak ada perubahan. QD and bus QD, just leave it as it is. Alright, next we have QCLB and QCUB, the range of the reactive power for the capacitor. Okay, kalau you tengok dalam this program, this is the range for single capacitor, where as you can see, the range of the capacitor reactive power is set from 20 to 80 mega VAR. Okay, but what about for multiple capacitor placement? Katakanlah you nak install 4 capacitor as in your mini project. Okay, you ada 4 capacitor. Do you need 4 QCLB and 4 QCUB? Okay, for the purpose of simplicity, I suggest you to have only one range for all capacitors. Maksudnya untuk keempat-empat capacitor tu range dia sama. First capacitor pun 20 until 80, second pun sama 20 until 80, third and fourth pun sama. Okay, for the purpose of simplicity. Tapi boleh tak kalau you nak ada different range of capacitor? Boleh, tak ada masalah. So that means you need to have 4 different range of reactive power lah. You kena ada QCLB1, QCLB2, QCLB3 and QCLB4. And then the same goes for QCUB1, 2, 3 and 4. Tapi kalau buat macam tu leceh sikit lah kerja you. Okay? Saya cadangkan you pakai okay, ke satu range pun dah cukup. Alright, next we go to bus QC. So this bus QC is only intended for single capacitor. So what about if you have 4 capacitor? That means you need to add 3 more locations. You kena ada bus QC1, lepas tu bawah dia bus QC2, bus QC3 and bus QC4. So you kena tambah sikit kat sini. Ini location untuk capacitor placement tambah supaya jadi 4 capacitor. Alright. Okay. Next, we go to random population generation. So because of we have multiple capacitor placement, which is in this case 4 capacitors. So this QC, the random value of the capacitors is also changed to 4 values. Okay. Boleh letaklah QC1, lepas tu bawah dia pula QC2, QC3 and QC4. Okay, ini pun you kena ubah sikit. Ada 4 nilai QC lah ya. Copy paste je lah ya. QC1, bawah dia QC2, lepas tu QC3 and QC4. The same equation. Using the same equation. Alright, next. Fitness evaluation. Okay, this is the most critical part in your source code. Ini you kena ubah dia punya test system. The subroutine of power system. Alright, let us open the subprogram test_14 bus. Okay, so this is the subroutine of test_14 bus. Okay, as you can see here, the parameters inside the bracket, first we have the QD, followed by bus QD. Okay, ini tak kacau lah. This is about reactive loading, QD and bus QD, regardless of the number of the capacitors that you use. Okay, after bus QD, we have QC bracket II, comma, bus_QC. That is for single capacitor. So if you have 4 capacitors, that means you have to add QC1, bus QC1, QC2, bus QC2, QC3, and so on sampai last capacitor. So this is according to the number of the capacitors that you use in the power system. Ini pun kena tambah sikit. So you kena tambah dalam bracket ni dia punya QC and bus QC for all capacitors, for the 4 capacitors. So when you have change here, the same goes for the subroutine. So katakanlah you dah tambah sini, QC1, bus QC1 sampai QC4, bus QC4, you just copy and then paste here. Okay, dia kena sama. The number of the parameters inside the bracket must be tally. Dia kena tally. Kalau sini ada berapa? 1, 2, 3, 4. 4 parameters. Then in the subroutine, you need also 1, 2, 3, and 4 parameters inside the bracket. So whatever number of the parameters that you change in the main program, the same goes for the subroutine. Alright. So after that, apabila dia dah buat test_14 bus, conduct the load flow analysis and obtain the value of Vmin and PLOS. Okay. So that's what happened when you change the number of the capacitors. So the number of the input parameters inside the bracket is changed. Alright, next we go to bus data and line data. Okay, this is still test_14 bus. Okay, yang saya buat ni 14 bus, tapi you kena buat yang 30 bus lah ya. Jangan ikut yang ni pula. Cuma saya bagi tahu dekat tempat-tempat yang you kena buat, yang you kena modify. Alright, bus data and line data replace with 30 bus. After the line data, we have substitute the desired load power. Okay, this is where you have to change a little bit. Okay, bus data, bus QD equals to QD. Ini tak ada perubahan. This is related to reactive power loading. After that, replacement of QC into the bus data. Okay, bus data bracket bus QC column 11 equals QC. This is just for single capacitor. So kalau you ada 4 capacitor, that means you have to add 3 more capacitors. Bawah ni kena ada lagi lah. Bus data bus QC2 pula. Bus data bus QC3 and then bus data bus QC4. So ini QC1. Lepas QC1, bawah dia QC2. Bawah dia lagi QC3 dan seterusnya. Okay. So ini kena tambah for the capacitors. Okay. For the multiple capacitors. So after you have add the number of the capacitors, then simulate the load flow analysis. This does not change, tak berubah. Then obtain the value of V min as well as the losses. That's it. Okay. Yang you kena tambah ini, the capacitors, QC, bus data, bus QC, and the number of the input parameters inside the brackets. Okay. Right. So once you have complete the modification on the test system, then we just record the V min and insert into record V min. Ini tak ada masalah, tak berubah. Okay. Alright, so far boleh ikut ya? Are you follow? Are you following? Okay.
Yes, sir.
Alright, good. Alright, next, after we have performed the fitness evaluation to obtain the value of V min and P loss, next we have to record the value of the 4 capacitors as well as the fitness. In this case, the fitness is still the voltage magnitude, which is V min. Okay, parent individual. Okay, remember that parent individual is to store the value of the control variables. The control variable in this case is the reactive power of the capacitor. So kalau you ada single capacitor, we just replace with QC, that's it. But now we have 4 capacitors to be recorded. So that's why I modify to be parent individuals equals to bracket QC1, QC2, QC3 and QC4. Okay, ada 4 kapasitor lah. So dalam parent individual you ada kolom 1 untuk QC1, kolom 2 QC2, kolom 3 QC3 and kolom 4 QC4. Okay. Parent fitness tak berubah lah ya. Parent fitness ni dia cuma ada satu kolom je lah. We still have V min as the fitness. Okay, next. So the parent individual combined together with the parent fitness in a large matrix called as parent. So this parent matrix represent the parent population of EP. So dalam parent population ni ada parent individual, kolom 1 sampai kolom 4 dan parent fitness which is the V min at column number apa? What column of the fitness?
Column 2.
Kan sekarang ni ada 4 control variable ni. Kolom yang keberapa? V min.
2.
Kan?
4, 5.
5. Okay. So you kena faham dia punya ni lah. You tengok sini ya. Parent individual diikuti dengan parent fitness. Jadi parent individual tu saja pun dah ambil kolom 1 sampai kolom 4. So after 4 is 5. So that is where your fitness is stored at column number 5. So saya nak you faham ni sebab saya tak nak you just modify je lah apa yang Dr. Zul cakap, aku tak faham benda pun. Saya tak nak you macam tu, okay? Saya nak you faham kenapa dia 5, kenapa dia 2, kenapa 1 hingga 4. Okay? Because you know the location of the control variable as well as the fitness. Alright. So after we have combined the parent individual and the corresponding fitness, next we sort the parent population based on the fitness. Okay, yang terbaik akan letak di paling atas, yang tercorot akan letak di paling bawah. Tapi nak sort tu sort based on what? Based on the fitness, and the fitness is stored at location column number 5. That's why sort rows parent, comma, negative 5. Okay, negative tu saya tak nak cerita lah apa benda. But you know that 5 because V min is stored at column number 5. Alright. So after we have sort the parent population according to the quality of the fitness, then we have to restore back, okay, the parent individual and parent fitness. So parent individual is taken from parent matrix from column number 1 until column number 4. Then parent fitness is taken from parent population at column number 5 only. Okay, so maksudnya dalam parent individual selepas ni, it is the parent individual and parent fitness after being sorted, selepas dah disusun. Okay. Alright, any questions so far? Because before we proceed for mutation, any question you would like to ask? Tak ada soalan. Okay, so next we jump into the main algorithm of ET. Okay, the mutation loop. Okay, so in this mutation loop, because now we have 4 control variables, QC1, QC2, QC3, and QC4. So we want to perform the mutation simultaneously for all the capacitors. Kita nak buat lump sum terus sekaligus. Bukan kata, mula-mula buat mutation untuk QC1 dulu. Lepas tu, habis QC1, buat mutation untuk QC2. Lepas tu, QC3, and then QC4. No. It will not be like that because it will take lots of modification on the existing program. Jadi macam mana kita nak buat sekaligus tanpa melibatkan modification yang begitu obvious. So first of all, parent individual. Okay, parent individual. Okay, bear in mind that it has 4 columns. Column 1 QC1, column 2 QC2, QC3, and QC4. So this XI, okay, it extracts the value of parent individual at column M. Okay, untuk individual yang M ni katakanlah 1. Okay, so katakanlah M ni sama dengan 1. So XI parent individual at the first row for all columns. Maksudnya untuk keempat-empat QC tu. Kolom 1 dia ambil ke semua terus. QC1 dia ambil, QC2 dia ambil, 3 dia ambil, 4 dia ambil. So this will be your XI. Okay, dalam XI tu ada keempat-empat nilai kapasitor. Okay, dia tak sama macam you buat apa assignment tu kan. Assignment tu XI cuma ada satu value je. Itu sebab satu control variable. Now we have 4 control variables. Okay, next. FI parent fitness. Okay, fitness tak ada masalah. Fitness we have only 1 column, which is Vmin. Tak ada perubahan. Alright. Xmin and Xmax. Okay, kita tengok Xmin dulu. Okay, sebelum ni, kalau untuk quadratic case, okay, Xmin means that untuk kesemua individual, katakanlah individu 1, 2, 3 sampai 10 individual, siapa yang minimum nilai X dia, that will be assigned as Xmin. Tapi untuk this case, setiap individu tu ada 4 columns. First individual ada 1, 2, 3, 4. Second individual 1, 2, 3, 4. Sampailah last individual 1, 2, 3, 4. Jadi untuk setiap kolom 1 siapa Xmin, kolom 2 siapa Xmin, kolom 3 siapa Xmin, kolom 4 pun siapa Xmin. Itu yang kita cuma nak buat sekarang ni. But how to represent this in the form of source code? So we just put parent individual for all individuals, maksudnya for all rows, column number 1 until 4. Okay, so as a result, you will have the value of Xmin to be like this. Okay, maksudnya Xmin tu ada 4 kolom. QC1 min, QC2 min, QC3 min, and QC4 min. And then the same goes for Xmax. Alright, so dalam Xmax ni, untuk kesemua individual, kolom pertama siapa yang maksimum, kolom kedua siapa yang maksimum, 3 and 4. So we just replace the column from 1 until 4, and this is what we have for Xmax. Xmax bracket, dia akan ada QC1 max, QC2 max, 3 max, and 4 max. Jadi you tengok sekarang ni, from Xi, Xmin, as well as Xmax, semua ada 4 columns. Okay, next we go to Fmax. Okay, Fmax parent fitness tak ada perubahan lah ya, tak payah kacau. Okay, sigma pun sama lah ya. Sigma equals to beta Xmax minus Xmin times Fi over Fmax. Because of Xmax and Xmin have 4 columns, the value of sigma is also 4 columns. Okay, in the form of 4 columns. So you will have sigma 1, sigma 2, sigma 3, and sigma 4. So send this sigma matrix into Gauss EP so that we will have set 1. Set 1 ni pun sama jugalah, dia akan ada 4 nilai. Okay, so finally we just perform the mutation x new xi plus imaginary set 1. So this is what we have for x new, the value of the capacitor for offspring pun ada 4 juga, x new 1, x new 2, x new 3, and x new 4. Okay, nampak tak? Kita buat sekaligus, tak perlu buat one by one. Okay, pertama from line number 44 to line number 52 untuk QC1. Lepas tu copy lagi sekali 44 to 52 untuk QC2. Lambat macam tu. Okay, boleh juga, tak salah pun, cuma dia lambat. Okay, tu nak kena buat banyak modification. Alright, so that's for mutation of parents to have offspring, which is x new. So x new you akan ada 4 nilai, 4 columns, and this x new is actually our offspring individual. Okay, so offspring individual ni you kena tambah sikit lah, comma all columns. Okay, apabila, okay, kalau dalam quadratic case, okay, quadratic case kita cuma ada satu kolom kan, sebab you cuma ada satu nilai x. So offspring individual ni saya cuma letak bracket M, that's it, sebab satu kolom je. But in this case we have multiple columns because of multiple capacitor installation. So you kena tambah offspring individual, comma all columns. Masukkan semua kolom untuk x new. So as a result, your offspring individual will have column 1, column 2, column 3, and column 4. Okay, so that's all about mutation. Next, perform the constraint handling. So in order to make sure the value of the x new produced from the mutation within the range that we set, okay, between QC LB until QC UB. So apa yang perlu kita buat? Kita cuma letak sini lah, okay. Offspring individual QC UB, offspring individual QC LB, but with the addition of column, comma all columns. Ini pun sama, comma all columns. Okay, untuk keempat kapasitor tersebut. Okay, tambah yang tu saja. Okay, next offspring individual pun sama juga, tambah all columns. Okay, comma column. Ini pun sama, comma column. QC UB, flag UB, QC LB, flag B. Okay, that's it. So untuk offspring individual, you just add comma and then colon. Sebab sekarang you ada 4 capacitor. Okay, that's all for constraint handling. Alright, next we go to fitness evaluation of offspring. Sekarang ni kita nak evaluate the fitness of offspring. Sekejap ya. Apa ni? Okay, apa? Okay, so cara dia sama jugalah. Before you can perform the load flow to obtain the value of Vmin and losses, first of all, you have to change the test underscore 14 bus. Okay, the number of the input parameters inside the bracket must be changed. Yang dalam ni ya. QD, bus QD, okay, tak ada masalah. And then QC new, bus QC. Okay, QC new, bus QC. Ini untuk single capacitor. So if you have 4 capacitors, that means QC new 1, bus QC, QC new 2, bus QC2, QC new 3, bus QC3, and so on. Kena tambah sikit. Okay, but before that, you have to define here what is your QC new 1, 2, 3, and 4. So, okay, QC new 1, offspring individual M kolom 1. Lepas tu, copy lagi. Bawah ni pula. QC new 2, offspring individual M kolom yang kedua. Tambah lagi QC new 3, kolom yang ketiga. QC new 4, kolom yang keempat. So once you have defined what is your QC new 1, 2, 3 and 4, barulah you boleh masukkan dekat dalam bracket ni. Okay? Itu sahaja untuk fitness evaluation. So after you have modify for the number of input parameters inside the bracket, perform the load flow to get the Vmin, and then Vmin store into offspring fitness. Okay, ini tak ada perubahan. Okay, this remains as it is. Alright, that's it for offspring mutation. Any question before I proceed to combine, sort and selection? Any question please?
Sir,
Yep.
yang bahagian constraint handling kan? Kalau
Bahagian mana?
constraint handling.
Okay.
Kalau kita guna boundary dia lain-lain macam
Boundary?
yang berlainan.
Okay, kalau berlainan, you just tambah kat sini. Bracket QC UB1, QC UB2, seterusnya tutup bracket balik. Macam tu. Kalau nak buat macam tu lah. Okay. Tapi saya cadangkan pakai satu range pun dah cukup. Tapi terpulang lah kalau macam you rasa nak make it different for every capacitor, terpulang pada you. Okay. Kalau nak mudah, pakai satu range je. Kalau nak susah, pakai different range. Okay, it's up to you. Okay. Then we proceed to combine and sort. Combine sort ni senang je lah. Tak ada perubahan pun. So parent individual, parent fitness tak ada perubahan. Offspring individual, offspring fitness pun tak ada perubahan. Combine parent offspring tak ada perubahan. Combine sort rows, but here you have to change according to the column of fitness, which is column 5. Alright, good. Then selection. Okay, selection parent individual. Okay, parent individual we extract from row 1 until row population, column 1 until column 4. Ingat ya, because we have 4 capacitors, kita nak ambil dari kolom 1 sampai kolom 4 sahaja, masukkan ke dalam parent individual. Okay, lepas tu parent fitness pun samalah. Okay, daripada row 1 sampai row pop, but we want to take only the fitness which is at column number 5. Column number 5 tu masukkan ke dalam parent fitness matrix. Okay, so this will be the next parent for the next iteration. Okay, display the parent population. Ini tak ada perubahan, skip. Convergent check, parent fitness max, parent fitness mean, max tolak mean, ini pun tak ada perubahan. Different fitness pun tak ada perubahan, break tak ada perubahan. Okay, habis. Sampailah TOC, display optimization accuracy, ini pun tak ada perubahan. But here you need a little modification. Okay, load flow simulation without capacitor and load flow simulation with capacitor. Okay, macam mana nak ubah ni? Okay, because it involves test underscore 14 bus. So as usual, you have to increase the number of the input parameters inside the brackets. Okay, so you ada 4 capacitor, tambahkan kepada 4 capacitor. So ini pun samalah. QC, letak QC1 sama dengan kosong, QC2 sama dengan kosong, QC3 pun sama dengan kosong. Last kali QC4. Ini kenapa sama dengan kosong? Because we want to simulate the test system without capacitor. So we want to observe what are the voltage and the losses before capacitor. Sebab tu kita letak dia punya QC dia kosong. Okay, tambah untuk 1, 2, 3, 4. Itu sahaja. And then the same goes for load flow simulation with capacitor. Okay. So you have QC1 ambil dekat parent itu, that will be QC1, and then QC2 sama dengan parent row yang paling atas sekali, satu koma kolom yang keberapa, kolom yang kedua pula untuk QC2, proceed untuk QC3, proceed for QC4. Lepas tu increase the number of input parameters untuk QC1 bus QC1 sampailah QC4 bus QC4. Okay, then you will have the voltage and the losses after installing capacitor. So finally, we just want to display the results, the overall results, okay, to see whether the capacitor installation using EP gives some improvement on the voltage or the losses. Okay, kita just display untuk QC1, QC2, QC3 and QC4. Lepas tu apakah Vmin dia before dan after, and V-loss before and after. Okay, let us take a look on the simulation of this program. Kita tutup dulu ya. Kita tengok yang single dulu. EP1 capacitor. Okay, saya buat yang single lah ya. Yang multiple saya tak buat pun. Okay, saya nak you buat itu. That will be your task untuk you punya mini project. Okay, so saya katakanlah saya letak the range of the reactive power for QC is taken from 20 to 40 mega VAR, and the location of installation for the capacitor is at bus number 10. The reactive loading that I give to the system is 50 mega VAR at bus number 14. Okay, let us take a look what happened. Control A, F9. Okay, lama sikit lah, tunggu sekejap. Alright, so as you can see the results, QC as a result of EP optimization, it find the value of QC to be 39.4119 mega VAR. That is the size of the capacitor. So as a result of the reactive loading, disebabkan kita bagi gangguan ataupun reactive loading pada sistem berkenaan, the voltage has dropped, okay, to 0.8464 per unit. But after we have installed the capacitor, this voltage has been increased to 0.8825 per unit. Adalah sedikit peningkatan, cuma it is not a significant improvement because the required voltage magnitude, the minimum magnitude should be 0.95. So that means you have to modify the setting of EP. Mungkin you kena letak capacitor tu dekat tempat lain pula, ataupun increase the range QLB to QUB, and then the losses, as you can see, has reduced 20.8162 reduced to 19.8125 megawatts. Okay, there is an improvement but not too significant. Okay, apa yang kita buat? Kita naikkan lagi dia punya. Katakanlah saya nak install dekat bus 13. Capacitor is installed at bus 13, and the range of the reactive power for the capacitor I increase to 80 mega VAR. Then let's see what happens. Control A, F9. Okay, so as you can see, QC has the value of QC determined from EP is 76.0816 mega VAR. the voltage is managed to be improved from 0.8464 per unit to 0.9327 per unit. It is quite significant improvement on the voltage magnitude. Kalau tadi you tengok 0.88 kan, tapi yang ni bila saya naikkan range dia dan ubah dia punya rotation, voltage dia dah naik sikit 0.93. Memanglah you kata alah 0.93 ni masih rendah daripada 0.95 so. Yes, but don't worry because you have the second task after this, which is multiple capacitor placement using EP. Sebab itulah kita nak kena conduct multiple capacitor installation, because single capacitor installation is not enough to improve the system at this very critical situation of reactive loading. Kalau you tengok tadi reactive loading, okay, bila saya letak 50 mega VAR dekat bus 14, voltage dia drop 0.85 per unit, which is a very low magnitude of the voltage. It's quite an extreme voltage, low voltage magnitude. So mungkin kita kena adjust sikit dia punya reactive loading tu, jangan terlampau tinggi sangat. Okay, mungkin kita letak instead of 50 mega VAR, kita letak dalam 30 mega VAR, let's say, so that the voltage reduce maybe to 0.91 per unit. So dari situ barulah kita tengok improvement dia is quite significant. Okay, and then the losses. Okay, as you can see, the losses reduction is not very significant. 20.8162 megawatts reduced to 20.4918 megawatt. Bila tolak dapat berapa? Dalam 0.4, 0.3 something kan. It's not very significant. Why? Because this EP program, it is programmed according to the fitness of voltage rather than losses. Jadi dia punya guide dia sekarang ni adalah voltage. Matlamat dia sekarang ni adalah voltage, bukan losses. Sebab tu voltage dia improve banyak, tapi losses macam so-so je. So kalau kata kita nak guarantee the simultaneous improvement of voltage as well as losses, then we have to go for multi-objective optimization, yang mana saya tak ajar lah dalam syllabus ni. Okay, saya ajar single objective je. Cukup lah untuk you ya. Kalau you nak buat multi-objective, mungkin you kena go for master ke. Siapa yang sama master program ataupun yang berminat nak buat final year project dalam EP, dalam optimization, bolehlah buat multi-objective. So multi-objective, dia akan consider kedua-dua sekali objektif. Vmin pun dia nak improve, losses pun dia nak improve. So dia akan dapat result yang lebih cantik lah. Cuma coding dia akan jadi lebih complicated. Alright, apa lagi saya nak beritahu? Okay, katakanlah saya kurangkan sikit dia punya loading. 50 ni macam terlampau tinggi. Voltage dia drop sampai 0.85 kan. Kita kurangkan sikit lah bebanan dia. Dalam 30 cukup lah. Tengok. Kalau 30, berapa dia punya Vmin dia? Vmin dia... Okay. Control A, F9. Okay, silakan. Tak perlu. Cuma task 1, result from task 1 tu, you boleh gunakan untuk task 2. Katakanlah dalam task 1, okay, bila you letak kapasiti dia 30 mega VAR, result dia dapat improvement. So you boleh set lah, okay, untuk task 2 nanti, you tahu 30 mega VAR tu is the best value. Mungkin you nak letak antara 25 until 35. Faham tak? Maksudnya range tu tidak terlampau jauh. Antara 25 mega VAR until 35 mega VAR. Sebab you tahu 30 tu nilai yang the best. Tapi mungkin ada lagi nilai yang ada lagi nilai yang lebih baik. Mungkin 29 point something ataupun 30 point something. You tak tahu. So that's why we have to use EP. Dia terpulang pada you. Amirul Terpulang. Kalau you tak nak guna, you tak nak ikut result task 1 pun tak apa. Okay. Boleh, tak ada masalah. Cuma sekarang ni apa yang saya nak you highlight nanti dalam you punya report, there will be advantage and disadvantages of using random capacity placement. Okay. So you boleh compare kat situ. Bila you gunakan random, mungkin dia senang, okay, tak susah, tak perlu coding yang complicated, cuma result dia tidak berapa satisfy. Contoh macam tu lah. Okay, you can make comparison between task 1 and task 2 using EP and without using EP. Okay. Boleh. Itu lagi cantik. Sebab kita nampak comparison dia lebih adil. Okay. Katakanlah you buat loading, you 30 MBR. Lepas tu you install dekat bus nombor 10 without EP. You dapat improvement untuk voltage dan losses berapa. And then dalam EP task tu nanti pun you masih lagi install dekat bus 10, loading dia pun masih lagi sama 30 MBR. And then you perform EP. Siapa lagi bagus antara min dengan losses dia? Itu lagi cantik lah ya. Tapi kalau you tak nak buat sama pun tak apa. Okay, sama-sama. Okay, kelas, tengok kalau saya dah kurangkan dia punya loading. Tadi saya ambil loading dia terlampau tinggi tau, 50 MVAR, voltage drop to 0.85. Itu orang kata dah sangat critical dia punya loading. Jadi saya kurangkan reactive loading dia to 30 MVAR. So the voltage drop to 0.90 only. And as a result, after we perform the capacitor placement, the voltage is managed to be improved to 0.988 per unit. Ini baru acceptable. Okay. So the losses dia pula meningkat. Tak apa. You record sahaja. Walaupun losses meningkat memang tak bagus. Macam saya explain tadi, because of this program, we code this program where the fitness is the voltage. So the program will focus the voltage as the guide for optimization. Dia takkan tengok losses. Dia hanya tengok voltage saja. Sebab tu you dapat voltage bagus tapi losses tak bagus. It's okay, tak apa. Record whatever result that you get from your programming. Okay, so any question before I terminate this class? Any question please? Tak ada soalan ya? Semua faham. Alhamdulillah. Okay, so maybe this will be the last lecture. Minggu depan kalau saya buat pun bukan, it's not about lesson lagi lah ya. It is just to monitor your results and your progress. Okay, saya cuma nak tahu progress je lah. Kalau saya nak buat lah ya untuk next week. Lepas tu your deadline for report submission will be on 22nd of January, 12 PM. Sebelum pukul 12 pada 22 Januari, hari Jumaat. Okay, boleh ya? Apa nanti saya tulis balik dalam grup. Okay, no question. Alright, I hope all of you understand and manage to modify your program for the purpose of multiple capacitor placement. Anything that you would like to ask, you can WhatsApp through our group or personal WhatsApp with me. Alright, thank you. Assalamualaikum warahmatullahi wabarakatuh. All the best for your mini project. Okay, thank you.
Thank you, sir.
Thank you.
Okay, thank you.
Thank you, sir.
Okay.